Hello. Excellent. Yep.
Hey, Vitalik, can you hear me? Oh, you're on mute, Vitalik, on Hangouts.
Yes, I can hear you, Hudson.
Perfect. Robert, can you hear me?
Yes, I can.
Excellent. Andre?
Yes, I can hear you. I'm here with Yoichi and
Conrad.
Yeah.
Dimitri.
Hi.
Hello. Awesome. All right, I think we can get started. So, let's see. Oh, I'm on the wrong agenda. Here we go. See, I put a link to the agenda in the chat. I also put a link to the troll box. And the first item is EIP 206, the revert opcode. Yoichi had a question about it, so Yoichi, you can go ahead with that.
What?
Oh, sorry. Probably should be more specific.
Can you say please for the moment? I have to remember what it was.
Oh, yeah, no problem. Jeff, you had a question over the atomicity of ECDA accounts on EIP 208 for transaction and signature abstraction.
Yeah, that's correct. So the issue here, I think it's easiest to understand in the context of, for example, ECDSA accounts right now trying to use ENS. So basically, the fact that ECDSA accounts can only do one operation at a time means that they can't do something like look up a name and then do a transaction to the address it resolves to, or something like that. Obviously, if we move to contract-based, a new contract for ECDSA, then that would potentially have the ability to perform multiple operations atomically. So then my question was mainly about, do we expect everyone in ECDSA to move over to contract-based accounts? Is that kind of the plan? Or if not, do we need to deal with the atomicity issue some other way?
So my personal preference would be that in the long term we should move everyone into EIP86 contracts. But realistically speaking, I do think that if we're going to make the transition compulsory, that's something that we should do slowly and carefully. And if it loses backwards compatibility, possibly over a fairly long duration. So it's like in the long term, personally, I do feel like making every account be contract based is better because like it reduces the number of classes of things that the protocol has to be able to deal with. But basically, there's a couple of challenges. So one of them is that if we want to make some kind of compulsory transition, then we might still have to keep the old well, actually, no. It's not really a problem to keep the old addressing scheme because we can just like swap the code over in place for something that basically does the exact same thing. I guess the main challenge would be that, as you said in your post, that it would break tx.origin.
Right, and I just saw your reply about asking for a concrete use case, and I have one about the issue with tx.origin. So right now, tx.origin is the only way to attribute the difference between who published a response in a state channel and who signed a response. And since we expect there to be like third-party transaction publishing services for state channels, then it's actually quite an important role at present.
And why do you want to know in protocol who published the response?
Basically so that you can, on the one hand, pay rewards and bounties for people who published transactions for you while you weren't available or online. And on the other side, so that you can differentiate between like a publicly claimed bounty where anyone might be actually publishing the transaction versus something that's just coming in through a forwarding contract. So like right now, the way that you accept signed messages from strangers, this might be different post-Metropolis, but the way that you submit the signed messages of strangers is that you need to set up a ECDSA validating forwarding contract that's a member of, say, the multisig that controls the channel. So tx.origin is really the only way to identify who's submitting the message because you're using the forwarding contract as the validation of ownership. So you're already using message.sender.
Okay. Okay, so in that case, I guess there's two. So with tx.origin, right, there's two things that we could possibly do, where one of them is to basically do nothing and let the opcode deprecate itself, and the other is that we do this change where if tx.sender is the null sender, then we basically switch tx.origin to being the tx.to account. And I think I may have mentioned that like personally speaking, I am happy with both, and if we decide that there is enough value in letting people know who the origin is, then I'd be totally happy taking that road.
So I think setting it to the to account isn't quite enough. If you have contracts which would manage multiple accounts, like verifying some other signature scheme, but anybody could create an account in that contract. Rather, you would just have the contract be able to set tx.origin as it prefers, but only if it's the first call in the chain to do that. So
you could, so if the goal that you're trying to meet is to be able to have generic contracts for verifying specific signature algorithms, then you probably do not want to have a workflow that says like null sender calls the signature verifier calls the account. You'd probably want null sender calls the account, then the account calls the signature verifier applies 0 or 1 to the account, and then the account does its thing. And the rationale for that would be that on the one hand, you would have, So on the one hand, it would be cleaner from a tx.origin perspective, and on the other hand, you would also be able to use the signature verifier for applications other than being the single signature verifier inside for a forwarding contract. So like one example is that if, let's say that we have a contract in a library whose purpose is to be, let's say, a Lamport signature verifier. Now let's say I want to have an account, and I want that account to be a 2 of 3 multi-sig of Lamport signatures. Then that's something that if we just make signature verifiers just like be libraries that return 0 or 1, that could just be constructed very easily because you just like call the Lamport signature verifier 3 times. Whereas if you made it follow this kind of forwarding pattern where like null sender calls signature verifier calls the account, so that would be harder to compose.
Sure, yeah, I think that makes sense, but speaking strictly from a flexibility perspective, I'd rather not set it up in a way that shoehorns us into one mode of implementation.
So the other challenge with allowing, if you actually allow it to set tx.origin, is that that's a security loophole, right? Because a malicious contract can set a weird tx.origin that doesn't belong to it.
I mean, I think you could say that like you could have an opcode that sets the tx.origin value to the message sender only if the tx.origin has not yet been set. But like that just seems weird, and I'm not convinced that the extra complexity is worth it over just like a simple and first check the TX sender, and if not, check the TX destination.
So I'm sorry, I didn't read up on this exact use case for state channels, but it sounded like you don't necessarily want to have tx.origin, but more like msd.sender of -2 or something like that. So 2 levels up in the call chain, or am I wrong there?
At present, it's tx.origin that you want. You don't need to go one more level in the call chain. And I think even if we switch to contract accounts, it would just be the -1, not 2 levels deep.
Mm-hmm. I mean, what about? So what we previously also discussed about tx.origin is in the presence of callbacks, may it be via some Oracle or a cross-shard call or something like that. Then tx.origin is actually not the person who published something, but tx.origin is just the service that did the callback. Would that still work for your use case?
Yeah, that could potentially be okay. I think you could plan around that. Sharding will require some planning around that sort of thing anyways, I think.
Yeah. And would there be a workaround?
Sorry, go ahead.
Would there be a workaround where this the account that currently is TX origin has to call into the state channel rewarding contract, whatever, to set their address, and then it is identified in that way? Would that work as a workaround?
It doesn't work the way you described, because the state channels don't look like state channels. They just look like multi-sigs, and the other random people who are publishing messages aren't members of them, so they don't have there is no place for them to call. There is nothing for them to register. You could set up a separate registry where they claim it, and then it sort of, I guess it would have to like atomically reset every time. Or I don't know. There could be some kind of weird workaround. And it definitely doesn't work if you don't have atomicity. Like at present, definitely it's impossible to do without tx.origin. But if we have atomicity, where you can have multiple operations inside of the same externally signed transaction, then you might be able to build a workaround.
I see. Okay.
One thing that I can say about tx.origin is that it's nice sometimes for it to be the person who's paying the gas. I've seen protocols where you want to refund whoever's paying the gas. And if like we lose the property that tx.origin is the person paying the gas, then that might not be that nice.
But for abstracted contract, that's not necessarily the case anymore, right? if we could have how are they called? These called R call style contracts where some other person pays for the gas, not the initial the TX origin contract.
So do we want a TX.gas pair? Is there a well-defined single gas pair?
Not necessarily.
That could be rough in the context of something like a mandatory gas price policy.
Yeah, and it could also be rough in the context of weird stuff where one guy pays for gas and in Makercoin and the other guy compensates him in Ether Doge.
Yeah, so that's actually kind of why I want there to be a TX.gas pair kind of thing.
I'm getting the kind of sense that maybe there's a better abstraction for what you guys want and need that is not TX.origin, but because something which is better suited for those purposes, but less likely to be abused like TX.origin for authority.
So the situation I'm describing isn't using TX.origin for authority. It's just using it for identifying who the original, who kicked off the chain of events, basically.
Yeah.
I have to say, paying for gas is the first good use case I've heard of for TX.origin.
Nick, didn't you do some just basic scanning of the network to see who's using TX.origin, or was that for something else?
That was something else. That was me trying to scan for things that tried to read past the end of call data.
That's right. Okay, never mind then.
That would be a useful thing to do, though, and it would actually be a lot simpler than the call data thing.
Okay, so there's a number of issues on EIP 208, so what we can do is, it sounds like we actually have found a use case for it in that case, so if you could maybe, well actually I don't know, would it be worth it for Nick to run something like that to see just how in use it is? I guess that could help determine if a different abstraction should be created in transaction origin than deprecated as long as it's not in wide use.
Informally, I'm fairly sure nobody's using it much to pay for gas because the issue is that the caller can grief you by seeing a very high gas price. But I agree that gathering data is probably a good idea, and I have been meaning to build some better stat stuff for a while, but I am kind of absurdly busy, and I'm not sure that Vitalik could be very happy if I took time off doing garbage collection in order to collect stats on TX.origin.
Yeah, I mean, it's just, whatever the priorities are, so, yeah, okay, cool. So, I think that, anyone else have comments on that?
So, please go ahead.
Yeah, I just have a question about gas price and account abstraction.
Mm-hmm.
Is it going to be possible to have different gas prices on different legs of an execution of a transaction?
So it's theoretically possible for accounts to pay the miner whatever amount they want if the miner is willing to accept it. So you could potentially have an account that has some weird policy where it pays 20 Shannon per gas in the outer call and then 10 Shannon for everything in the inner call. But I expect that miners would prefer to just accept transactions with uniform gas policies, basically because their incentives are primarily structured by the uniform gas limit and obviously the uniform on-call risk, or the kind of largely uniform on-call risk.
So
wait a second.
There's not going to be a gas price in the transactions anymore, except for kind of old style transactions?
Yeah, no. So EIP86 transactions have a gas price, but it's basically vestigial, or at least the gas price that the protocol is aware of is basically vestigial.
Christian, did you have a comment?
Yeah, so I mean, I was just thinking about whether there's there might be a way, there might be a solution where we delay the solution in some way, like for example, throw when someone uses TX origin inside a transaction that is initiated from an new style transaction or something like that. Yeah.
Yeah, I mean, yeah. So like the thing that we could potentially do is we could, or potentially the other thing we could do is just like do nothing to tx.origin right now, and then just like explicitly say, you know, we are probably going to change tx.origin behavior in the future, and then whenever we end up doing the next hard fork that starts making EIP or whatever hard fork starts making transitions to EIP86 accounts compulsory, that's the one where we'll figure out what's to do with tx.origin more properly.
When you say do nothing, you mean it becomes a null sender, right?
Yes.
I'd personally be in favor of doing that. Letting TX origin be the null sender, and then at some point in the future, address the situation with the legit use case here. And that might be tx.gas price, gas pay or whatever.
Yeah, at the moment, though, it doesn't seem like we have any kind of infrastructure to tell really who's paying gas. In some way, if the abstraction really just lets miners kind of arbitrarily decide to take compensation.
Well, to be fair, there's no such thing as an abstraction layer that doesn't let miners arbitrarily take compensation.
Yeah, I mean, you can like make them take at least some amount. You know, this.
Well, yes, but that's like totally different from not making them take compensation. Like you're conflating taxes and maximum wages.
So one issue with that proposal of just like leaving tx.origin to be the null sender during the intervening period and then worry about it later is that if for the state channels use case I was mentioning, that would actually leave a dead zone where if we didn't have like standards around atomicity for ECDSA transactions kind of in widespread use until we switched tx.origin, then in that intervening period, there would actually be no way to do the use case in state channels.
Well, no, there would still be the use. Oh, right, I see. So, like, there would still be the current way of doing things, but I guess you would not get the benefit of like Metropolis-style atomicity plus tx.origin gas payments. Although the one thing that I can say though is that you could create like inside of EIP86, you could create structures where some contract that's deeper down the call chain pays for the gas directly, instead of like compensating the tx.origin.
So for the state channels use, we're not trying to compensate for gas, so it doesn't work for that one. But
oh, right, I see. Well, hold on. You're trying to like compensate the guy who's including the.
So
right.
What you're trying to solve here is attribution, right? You want to do attribution to whoever manages to broadcast the transaction. One way to get that attribution would be just a data encoded signature of the person who tries to publish. That can, that has an issue that the miner can say, oh, cool, I could make some money, and then switches out the transaction. But
that's also just another point is that if you are going to rely on tx.origin for like creating a bribe that goes beyond covering gas payments, then that's a mechanism that's going to be trivially front-runnable by miners, because they can just like see what transactions they're collecting bounties and then replace them with transactions coming from themselves.
That's definitely true in this case as well. That's definitely a feature, not a bug, of anyone can pay scenarios. You don't if the miners are actively trying to front run these, it's better for the user because it just means that they're getting in even faster. It's even higher level of guarantees. There's no disadvantage to the user. And outside of the anyone can pay situation or the anyone can publish situation where you're contracting with someone specific, then if somebody else who isn't on the list submits it, they're not getting anything anyways. Then there's no front running risk.
Okay.
Okay, but then you can do the attribution via a data signature.
Sorry, you were cutting out a little bit. I didn't quite catch that.
Oh, sorry, I'm far away from the mic. I said for the attribution of who publishes the state, you can just use a signature that you attach to the transaction as data.
I think that makes sense, but I'm not sure I quite understand. Like, are you talking inside of a new contract style transaction or inside of an existing EOA transaction?
So if you, the transaction that publishes the state, there you include whatever the state channel state is that you want to send in, plus you sign that you are the person, you're the account who actually does the publishing.
Right. So that takes us back to the atomicity issue, which that you can't do two operations from an EOA. But
Okay.
So I think in the interest of time, would this be something we could flesh out on the EIP itself, and then also just bring up with the newer information next meeting?
Sure. Yeah.
Cool. Yeah, and I think that, yeah, this opens up a lot of new things we hadn't really thought about before with transaction origin, because I know we've been talking about it for a while, and Fabian's not in here, but he had also been a proponent for keeping transaction origin, so I'm sure he's going to want some to participate in some of the feedback in there. So back to the agenda. If everyone could just refresh the page, I added and took off some agenda items because Sophie, like the agenda item from Sophie is gone, and I added Martin's. So the next item actually it's a list of 3 concerns from Martin Holsvende on EIP 208. So same EIP we were just talking about. I'm not sure if any of these were touched in the conversation, but I'll let Martin take it away.
Yeah, so no, we haven't touched upon it yet. Basically, the thing is that with Metropolis, it's going to be possible to include the exact same transaction multiple times within a block. And I'm a bit curious about potential side effects that can have, side effects on the clients. And if that's something that we need to discuss and think about, basically.
Can you give an example of a side effect?
So one side effect is that we have the RPC interfaces, which needs to be changed potentially to return multiple transactions. Another potential side effect depends on how transactions are stored internally within clients. And if there are data structures which assume that one transaction hash equals exactly one execution and one receipt, then it can be in internally inconsistent state, stuff like that. And we have other RPC methods where you send in a transaction hash and you get one thing back. And we need to modify perhaps the parameter set for that so that it takes not only a hash, but also a hash, a block hash, and an index.
So just a quick comment here. Unless, because of that, there's some kind of intrinsic gigantic problem, this is not relevant for the hard fork itself because the feature won't be active, right?
What do you mean the feature won't be active?
We won't activate such transactions at the hard fork, only later.
I'm not sure I follow. They won't be active.
So there is the possibility that a malicious miner will, or we'll just say a miner who is not cooperating with or running default software will include 5 copies of the same transaction, right?
Right.
So
that's what I'm talking.
Yeah. So like
Right, okay.
what we can't. So like that is a good argument for why we don't need to care about the interfaces for accessing multiple copies of a transaction to be too convenient, because like if worst comes to worst, the only initial use cases for those will be transactions that are submitted by like basically extremely irregular users, and we can tell them to go build their own systems. But it is at the point where like the client should not break if 2 transactions of the same hash get into the blockchain.
Can we not consider whether there are straightforward changes we can make to restore the invariant that transaction hashes are unique?
Like the main challenge there is basically that like that would first of all bloat the state. Well, so in the current case, it would basically create like unending state bloat. And I mean, we could have transaction deadlines, but then that would still have a substantial state bloat, and that would still require an in-state garbage collection mechanism.
I mean, it would depend on how we did it. I mean, the simplest way would just be to reinstate nonces as the one required part of a transaction, and the rest of the signature verification is up to you. Another would be, for instance, to have a more generalized nonce scheme where transactions are expected to apply some transformation nonce.
Right. So I mean, I'd say in the long term there are legitimate. Well, so in the long term there are legitimate uses for. I mean, like first of all, making anti-replay completely liberalized, and I would say even just accepting the same hunk of data multiple times. So the key one that or one of the key ones that I'm thinking about, for example, is like if you have some particular thing that needs to get poked, and then the transaction that pokes it should really just be like a really minimal thing that has like no signature and nothing else, and it could just like say poke the Ethereum alarm clock, and then the Ethereum alarm clock doesn't sting. And I would say that it would be like added complexity for that sort of thing to have to require nonces and figure out where its nonces are coming from. I'd also say that there are going to be benefits from eventually moving the protocol to this regime where, as long as transactions are correctly formatted, they are valid no matter what. Basically, because it lets us do like weird stuff like agreeing on blocks and agreeing on state roots out of order.
Yeah, I mean, I agree nonces are suboptimal even under the current scheme. There are times when you want your transactions to be ordered, but there are other times when you really don't.
Yeah.
But I just, I don't know. I worry that this may be a more useful and a more pervasive invariant than we think, or than is immediately obvious.
Maybe we can just rely on logs instead of transactions.
On what, sorry?
Logs.
So like in general, we definitely should be moving toward relying on logs for things.
Yes, but I think that, I mean, transactions are still a fundamental component of the system, so we can't, where do we stand on transaction queuing? Because I remember one of the previous issues was that with the system, you can no longer rely on two transactions you submit being executed in the same order, because the miner could choose to execute the second one last, and then all your code can do is reject it, in which case it never gets executed.
Well, hold on. So if you have one thing that you can do, right, is if you're specifically talking about like regular users, then regular users are going to be using a whitelisted account, and the whitelisted account is going to have a non-scheme. And so if miners include one out of order, then when you process the block, you'll be able to tell that the transaction hit an error, and so you can just ignore it.
Right, but the issue is that you can't queue up, say, 5 transactions because the miner can
Why?
choose to. Well, because if it does choose to execute in reverse order, then
No, but the point is that the miner can totally choose to include the second one, but then the second one will return an error, and so you can just go ahead and return the second one.
Right,
or you can go ahead and include the second one.
The miner can just keep including your transactions out of order and charging you for it.
Who cares?
Well, I do if I'm paying for the gas.
No, but the point that I'm making is that including a transaction out of order is exactly equivalent to a no-op, except for wasting gas.
Right.
And so, like that, it should.
But I'm saying that that's bad because if it's a no-op, then you can force me to waste gas arbitrarily.
No, so miners can already waste gas arbitrarily. They've always had that freedom.
My gas?
Miners can waste their own gas arbitrarily, right? So remember that when your transaction gets included, so remember the mechanism that pays for gas is not something that like automatically deducts from your balance, right? The mechanism that pays for gas for an EIP86 transaction is itself EVM code that's inside that has to run. So if your transaction gets included out of order, then it gets included, and then it hits an error, it reverts, which means everything reverts, including the gas payment.
Okay, fair enough. But then I'm still in a position where I can't reliably queue stuff up, or if I want to, I have to remain online and active in order to respond.
Well, I'm still failing to see why the ability to include no-op transactions makes any difference whatsoever.
Well, so previously I could queue up 5 transactions, and I could be sure that either they will eventually make it into the chain, or nothing after them will. But now.
Well, hold on. So you could still replace the word "make it" with the phrase "make it into the chain" with the phrase "make it into the chain and have an effect."
Yes,
because that's what you ultimately care about, right?
Yeah. But if okay, so put it this way, I can currently broadcast transactions and then go offline and not care.
Yes, and here you'll be able to do the same thing.
But
you guys are slightly talking past each other. I don't know if you both realize it, but
I do wonder. Yeah.
Nick, what Vitalik is saying is that that miner including that no-op out-of-order transaction has no effect on other miners, just including it later to get actual gas. So it is effectively as if it was not included.
Okay. In that case, the other question is, how do we know when to discard transactions from the pending pool?
Yeah.
So you discard a transaction with nonce n when the transaction with nonce n or nonce higher than n gets included and successfully executes.
Right. So then our transaction pool implementation at least still needs to care about nonces.
Yeah.
Well, it still needs to care. Yeah.
Nonces, right?
Well, it needs to care about the in protocol nonces. Yeah. Or sorry, not in protocol. I mean, care about these nonces that are managed by account code. Yes.
Which may vary from account to account.
So initially, at least, we won't have any sane way to propagate non-nonce transactions then.
Yeah, a miner might try to execute them in a whole bunch of different orders and kind of give up because they can't find the nonces. Yeah. And they're not having effects.
Yeah, so if you have some in the kind of earliest version, if you have some application that relies on things other than nonsense, you'll have to go make a private agreement with the mining pool until we figure out something better.
I mean, we could, with the revert opcode, we have different ways to flag errors, right? So the nonce checking algorithm might signal to the miner, do not yet include this transaction, or this transaction cannot be included anymore in any future.
Yeah, this is something I suggested in the past. I think it'd be very good if there was some way for a transaction to communicate with limited gas what its status is in terms of inclusion, like whether it wants to be kept.
Yeah, I'd support making that be a default part of the default account.
But do you want to have a gas sender?
What do you mean a gas sender?
Like some account that the protocol knows to kind of check their balance to make sure that they have enough gas at a particular gas price to execute the transaction.
I mean, like that's all part of the default account code, right?
Yeah, but you can deviate from the default, substantially.
We can do what?
You can deviate from the default substantially and do implement something where there's no clear.
You can totally implement something completely weird, but then like miners will not accept it because it's not part of the White West, or like it doesn't match the filter. Right.
The miners will get to decide the filter. It's not like part of the
Correct.
protocol.
Yes, but like if miners decide a filter that's completely crazy, then that's their own fault, and they're the ones that lose money for it. Like miner B is if miner B uses our recommended filter, then they should not be negatively affected by miner A using a completely crazy filter.
So Martin, I think that I'm trying to keep up, but I believe that this discussion was over agenda item 1.3.1, I guess.
Mm-hmm.
Did you want to bring up the other points or conclude that point potentially?
No, I think we can conclude these 3 points. I just want a bit of discussion about how this affects the clients.
No, I think it's definitely something that's really worth discussing.
All right, cool. So we can bring this back to the EIP. Yeah, Martin, if you could kind of summarize this in an EIP comment, and then the others can kind of look there and comment further on it after, based on the discussions from this call as well.
Yeah, sure.
Thank you. Okay, so the next agenda item is A.4. So EIP 211, return data copy and return data size. Is that one good to go? Like I can merge the PR potentially, or were there any changes? I think this is Christian's, and it looks like Yoichi has reviewed it. Does anyone have any comments on that, Christian especially, on if it's done?
I forget. Did we agree on if you ask for data that goes beyond the return data boundaries? Did we agree that that's zeros, or do we agree that that's a throw?
We agreed that. Let me look real quick. Oh, a throwing approach rather than filling with zeros. I put a comment in the EAP that we decided that on the 2nd of June.
Okay, and that sounds good.
Cool, Christian.
And also, just another clarification is that the return data gets triggered by or gets reset by a call code, delegate call, or static call, but not a create, correct? Because creates have no return data.
I think we decided that it's reset on every time a new stack frame is created.
Okay, so on a create it gets reset to null, or?
Yes. On create instructions, it gets resetted because create instruction sometimes returns data when it fails.
Right, I see.
Also,
but then hold on. But like a create instruction, though. Oh, I see. So right now, though, the output of a create doesn't really go anywhere, right? Like it just.
There's a comment in the AP which says create and create two are considered to return the empty buffer in the success case and the failure data in the failure case.
Okay, that sounds good.
Okay, great. And I'm going to put a note in that EIP to clarify that after I take notes after the meeting. Christian, would you consider this done? I can merge it and stuff?
I think it can be merged, yes.
Sweet. Okay, if there's no other comments on that, item 1.5. So there was a comment on EIP 213, which involves the zk-snark verification primitives. There was a comment about, actually not even a comment. Basically, the thing left to do is to decide on gas cost. So I just wanted to bring that up because it's been about, good 20-25 days that people have been saying we need to decide on gas costs. So what is the general process for deciding on gas cost, or should that just be recommended by a client and then other people comment?
I would, so personally, I want to wait until we get the, actually, can we just like organize the gas per second values for Parity, C++, Geth, and Python in just one place? And see what they're like on all four of them. I'm especially interested in Geth because I don't think we've seen that yet.
And the question is also, do we want to make benchmarks on exactly the same machine for all implementations?
We can.
I think maybe Casey or Martin would know this. Do we have a testing system set up where we can spin up nodes from different clients to be able to run something like this on the same type of machine with the same specs?
Yeah, I mean we have, but I think what we've commonly done is for these measurements. I think what has been done is running it on a laptop, and I think it would be. I mean, it obviously makes sense to run it on the same laptop and do some measurements, but I don't know what the standard laptop would be. We do have now. I mean, we can run the EVM binaries for Parity and Geth isolated without the rest of the blockchain stuff, and do some measurements on that. I don't know if that would be enough, or if we want to do it a bit more reproducible.
Arkady or Robert, what has the Parity team done in regards to this, or have you all done gas estimation through Parity through a process ever?
Yeah, I did some benchmark for EC pairings, but not for addition and multiplication. I've posted the results earlier. I can probably run the same kind of benchmark for addition and whatever.
Sure.
But yeah,
so I don't
check on the same hardware.
So I don't think we care much about benchmarks for the addition because I personally expect that the gas cost for that opcode will be dominated by the gas cost for the call opcode anyway. But for multiplication and pairings, definitely.
Arkady, can you share the test cases you used for benchmarking?
Yeah, sure. I'll post them a bit later.
Yeah, I think it would be good if the benchmarking would be coordinated by a single person.
Sure.
Okay. I don't think anyone has time right now, but who wants to take that up? Yeah, and if no one does, we'll draw a name or out of a hat or do something creative.
Martin, couldn't you add a block test to Hive that basically just a full block that simply does all these opcodes and then just run it against the different clients?
Yeah, I'm not sure how stable that platform is with regards to
Okay, so in
virtualization and Docker, stuff like that.
Okay. Just saying that Hive does have support for some form of benchmarking, so maybe it will work, but maybe not.
Yeah, I mean, Hive can probably do it, but I'm not sure if I don't know how the Azure systems are on the same stuff every time around, or if it varies widely.
Oh, I didn't mean to run it on Azure. I meant just run it on locally.
Yeah.
We don't actually need the same person or machine to benchmark everything, do we? We can just benchmark against a known baseline like ECDSA signature validation.
So hardware has nothing to do with it, Nick? Like that won't affect stuff?
Well, if we determine that it's like twice as fast as our slowest operation, then we should price it at, on average across the implementations, or in worst case across the implementations, then we should price it at, half our worst operation.
Yeah, but there might be variations in the baseline itself across the implementations, so I'm not sure if that...
Right, but the implementations already have to be fast enough to keep up with the blockchain, and we presumably factored that in when we priced the gas for the existing operations.
Yeah, I think we can organize for all implementations to offer an isolated virtual machine binary to run, don't we?
Yeah, I think that's doable. Organizing it, I should say. So on the Gitter chat, let's talk about doing that. Brainstorm a little bit more. But yeah, it sounds like that would need to be done for actually any of the opcode related EAP changes. Am I correct, or are there some that are just kind of a given, or like we know already?
So most of the others are just variations of existing opcode, so nothing has to be determined there.
Okay. So yeah, let's either do a thing. Did anyone else have comments?
There was a discussion about benchmarking the new opcodes. I will say that we could easily add more tests for that in the blockchain test form. We could make a transaction that would call a single opcode so many times that block gas limit is allows. Like Vitalik said, 250 million gas limit is okay. And so we could spend all of that gas to call so many times in a specific opcode and see how it consumes the resources on every client through Hive.
Okay. Dimitri, would you be okay leading that, or at minimum getting kind of a chat together or organized, or using the all core dev chat to get support from the other clients and get that together? It sounds like this actually could fall into the testing wheelhouse.
And this test would be able to work on Hive. So we don't need any specific support from other clients. We could use Hive.
Okay, cool.
Yeah, regarding that though, I'm not sure, because Hive, then you will have also the added time.
Or if you mean that such a stress test might crash something on Hive, then the clients are required to implement a general state test or blockchain test at least.
Mm-hmm.
And then they could run this blockchain test through the testing tool, or they could just see the script in Hive and somehow implement it locally and run the block input process on their own environment. So
perhaps we could do both approaches, because I think one approach could be to do it in Hive, and another approach could be to run it as raw EVM code just against the EVM binary, and then we can see if the two measurements match each other.
I think we could add this issue to our documentation process, so to help us developers run benchmarking tests on their own environment with their own clients.
Yeah, that's a good point. I sent out a call on Reddit a few weeks ago to get people to help with Metropolis testing, and we had literally over 85 or 90 individual emails from people asking to help test, and I've also been getting some known community members who are wanting to help test. So we've written up some preliminary rough documentation and have a lot more resources written up on LLL and some of the stack and like EVM and assembly requirements to be able to do that. So we're going to release that today. I'm emailing all 95 people back, and then, or 85 people back, and then posting to Reddit again. So maybe we can set up like a spreadsheet for people who are testing on their own consumer hardware to put in what they're doing. A lot of people probably wouldn't have the knowledge and time to do that, but in combination with, you know, us doing it ourselves, I think that'd be a good benchmark. So yeah, okay, so it sounds like we'll talk more about this in the All Core Dev channel. Was there any other comments on that? Alright, cool. So item number 6 is going to be EIP 214 static call. Vitalik made a comment on various potential errors within that. in the static call EIP. So you can go ahead, Vitalik.
Yeah, like neither of these seem very controversial, but basically there's like the S-store bytes opcode referenced in there, and that opcode was one that I proposed about a year ago, but I've since withdrawn that proposal, and it doesn't exist, and that opcode doesn't exist, so that shouldn't be in there. And also, there's a sentence that says they also include call and delegate call with a non-zero value, but there's no such thing as the delegate call with a non-zero value because delegate call doesn't have a value as an argument. So those are two just like purely stylistic elements. And then a third one is that says something about the value. It says its value is always copied to subcalls or subcreates, and they are what's like. There's no such thing as a subcreate of a static call because a create inside a static call always fails. So like no substantive changes, but just like 3 things there in there that should be changed in the text because they refer to things that are not possible.
Okay, I think the second item. Wait a second. So sorry. So the first delegate call is meant to be a call code, I guess. So also include call and call code with a non-zero value. Would that sound better?
Hold on, but then the next sentence is, as an exception, call code is not considered state changing even with a non-zero value.
Okay, I'll take a look at the full context and modify it accordingly.
Cool. So does that finish up that item, Vitalik?
Yeah.
Okay, great. So item B, updates to testing. I just kind of explained some of the documentation and other updates from some of the stuff I've written up. Dimitri and Yoichi and like Martin, anybody else who's doing testing, do you want to kind of give your update on where we're at with that and some of the improvements?
This is Yoichi. I joined this testing effort like a month ago, and I'm new to the whole process, so I met many issues. So I'm trying to add documentation to this test command that produces test cases from sources. This documentation is in a late stage of the review, and I'm also changing test so that it causes errors when people make spelling mistakes in the command because I wasted lots of time not noticing I made a spelling mistake and so on. So I'm kind of doing guinea pig to this process and trying to fix problems.
Okay, and from my part, we created Docker image of the test set. So new contributors for tests could just use the Docker image and not bother with building from the so building CDP client and Solidity LSA compiler for test generation. And yeah, we're making a documentation how to use the test set and when it's inside the Docker container.
So does any one of you guys, Yuichi and Dmitry, have any kind of estimate about how much test coverage, Metropolis test coverage we have at the moment?
I could try to do that, I guess, 35%.
All right. Good.
All right. And I just posted in the Hangouts chat, and I'm also posting in the Gitter chat the documentation summary. So anybody who's interested in helping test, or if you know anybody who'd be interested in kind of getting more familiar with the internals of Ethereum and what we're doing with Metro, go ahead and pass them this. I'm going to also post this to Reddit right after we get done with this call. So let's see, where's the agenda? Cool. Does anybody else have updates to testing? Okay, great. So the details and implementations of the EIPs. Let's do updates from the client team. On the agenda, I put links to the pull request that kind of compiled or tracked what EIPs were being implemented per client. So we can start with Geth. Peter, do you have updates, or anybody else from the Geth team?
Sure. So we had a discussion yesterday about it, and with Jeff, he said that most of the EIPs are done. If you open a PR, I just updated the list, the description, so that there's a whole rundown. In theory, all the opcodes, or most of the EIPs are done. One of the EIP that Jeff missed, that I'm going to try to add on Monday, is EIP 96, the block hash stuff. So that one is not done, and Jeff is still tweaking the EIP 86 with regarding the create to opcode. Apart from this, I think Felix wants to revamp our internal tests so that we can properly test the Metropolis changes on our CIs, and let's see where that leads us. So in theory, it's mostly done, just the final tweaks are going in. In practice, we'll see after the tests.
All right, excellent. That's great. Parody, Arkady, or Robert?
Well, yeah, we've completed our implementation a while ago and did some smaller changes for whatever was discussed in past weeks. And yeah, we're also waiting on the test mostly.
Also for Modi XP, there's new gas cost calculations, but it seems in the discussion that maybe there will be even more updates to that. So we haven't quite got that ready yet.
Okay, great. That'll be useful when we're doing the comparisons across clients. So that's good news. Okay, great. CPP Ethereum. I think I have. Yeah, there's a PR that kind of lists some of the progress. So is Pavel here, or Christian? You can speak on it.
I think Andre knows more about it.
Oh yeah, Andre.
Yeah, during last 2 weeks we merged the block hash implementation and also built the curve precompiled, and also made a couple of minor fixes like throw on return data copy accessing out of bounds, and changing the modx gas cost. So what's left is create 2 opcode support. This also is almost ready, I think. And yeah, that's it.
Okay, great. Cool update. So on the yellow paper, Yoichi.
It's finished, but now the focus is more on how to get the previous Dragon thing merged. So.
Okay, great. And then Pytherium or Pyth app. I saw Jan was in here, but I think he had to drop off. So Vitalik, are you familiar with the update?
Let me see.
And while Vitalik's looking that up, are there other clients in this chat that I missed on the list? I think I got everybody who regularly attends meetings. And then also, while he's looking that up, does anyone have an update on Ethereum J and Roman's team? They haven't been in a meeting in a while, and I believe that pretty much all of their projects are stagnant right now. Does anyone had contact with Roman or his team in the last 2 to 4 weeks?
I am getting the feeling that they might not have enough resources to do all of this stuff, especially since a lot of their projects haven't gone far.
Yeah, I mean, there was a post from Gav that said that Roman was taking a break, but didn't give much details besides that, and they've been dead silent on their Slack for about a month. So I might try to reach out, but otherwise I think we should consider Java Ethereum client not to be up to date, along with Ruby and a few others.
Mm-hmm.
Cool. So yeah, Vitalik, whenever you find that, update, or if you want to just post it later in the comments, that's fine too.
Hold on, which update was this again?
Oh, just how far Pi Ethereum is, or I think
how far Pi Ethereum? Oh, right. I was trying to look this up, but the problem is that there isn't like one nice commit that I can point to. So what we do have is that I could just list stuff that I know is implemented, which is all of the precompiles, static call, revert. I believe return data, though possibly not with the change that makes it out of bounds stuff return an error. Then EIP 86 definitely. 96 not yet. 98 not yet. Like all of the ones that don't have to do with transactions, I'm waiting until we have blockchain tests for them. And revert opcode, yes, and all the other stuff, yes.
Okay, great. And are you primary on that, or is it Jan, or who's kind of doing most of the Python?
I've been primary on EIPs.
Okay, great. Just so I'm aware. Perfect. So the next thing on the list, because there were no other clients in the chat, review time estimates for testing and release. The last time estimate we had was between August and September for testing and release period. Does anyone have a comment on that, if it should be changed in any way? Okay, great. Yeah, sounds like from the testing update that we have and the potential that we might get an influx of testers who can accelerate that, we might know more next meeting. So any other comments on that?
Yeah, I'm excited to see these contributors. I feel some uncertainties how it goes. Maybe the overhead of answering questions and so on will overweigh in the first 1 or 2 weeks, but after that, I guess we can get it to the state where these additional people will make the process faster.
Yeah, I agree. And I think that we can kind of guide some of the people to also update some of the testing documentation as they're going along, to not have to go through the whole Gitter channel every time someone has a question. So yeah, that'll help that a lot. I think that was the last official agenda item. Does anyone have any other things they want to bring up? It can be non-agenda or whatever.
Okay, well, the skipped first agenda item, I remembered what it was.
Oh, that's right. Okay, great, Yoichi.
Yes. So the EAP, one sentence is missing from the EAP, and I will work with Alex B to fix that. The missing sentence would say the revert instruction returns data which would be available in the same way as return the data returned from the return instruction or something like that. That one sentence is missing from the specification section of this EAP. I can work with Alex B to solve this.
Okay, great. Perfect. Okay, cool. Then I think that covers everything. After that's changed, we can look it over. But yeah, it didn't look like a big change, like you mentioned. Cool. Any other topics or items or anything?
I'd kind of like to be caught up on any conversations that anyone's had about EAP 156.
Cool. Which one was that again? Let me look.
The stuck funds one.
That's right. Yeah. So that was brought up by, who was it? So I'm having to find it real quick. But basically, I talked to some exchanges fairly recently. There was a group on Skype who got together. it was actually more than exchanges. It was exchanges and then other interested parties in the EAP, and they basically asked me, so if we wanted to get this done, how do we get it done? And I gave them the whole process, which was, get community support, do an issue on the EAPs, then a formal EAP, and then kind of see which developers are interested in implementing, etc. And I think that the conclusion they came to at this point, what I feel like, and they can kind of answer for themselves in the EAP, was that they don't want to put in an EAP for that right now because it would be controversial and it would kind of seem like a whole nother thing, especially coming to Metropolis. The other thing is, at the point where we've pretty much locked down the EIPs, it would be too much time to test and also to figure out just a process for determining which stuck funds get out. Vitalik, I know you wrote the EIP. Do you have an updated summary of your thoughts on the EIP with the recent Quadriga CX hack and stuff like that? Or not
Yeah,
hack,
so
the other thing they did.
Right. So basically the challenge is that with Quadriga is basically that EIP 156 works well when you have an entire class of situations where you can very clearly identify that, first of all, you have an account where money is not accessible, and second, where you can identify who, a party that money should reasonably belong to, right? So one very natural case is if money goes into an empty contract, then you can probably sending the money to a creator is not that bad a thing to do. The challenge with the Quadriga case is basically that the money is stuck inside of a splitter contract, and the splitter with the splitter contract, it's much harder to we can mathematically reason and show that money is stuck because any transaction coming in will have the same amount coming out. But it's much harder to turn that into a kind of principled rule that would make sense to stick into the protocol, and it would. The other thing is obviously identifying basically whom to refund, where that money came from inside of the state, so that we know whom to refund to. So in general, I would really rather avoid making contorted rules that only apply to one specific case, because I feel those kinds of things and in general set bad precedents and should be should be done only in the most extreme situations. And whereas something where you could, if you can come up with some specific class of users where here's people where a case where a few thousand people lost money, and it was all done in the same way, and we have this kind of very clear and kind of unambiguous way of determining who a reasonable owner is, then it makes quite a bit more. Doing something like EIP 156 to recover the funds is quite a bit more reasonable.
And that would be the case of something like the implementation error in Ethereum JS util that caused some lost funds. Could that be entirely technically proven that they were lost because of that error?
Yes.
Okay. Cool.
Mm-hmm. So you might notice in specification version 2, I have a function declare lowercase hex address, and it does that.
Okay, and it sounds like the people who are the most vocal about this, and I mean it's not a huge amount of people, but the ones who are the most vocal do not fall in that category of something that can be easily checked you have in V2.
So there are basically three, at least I know of a few major categories of losses, right? So one of them is empty contracts, where either one case I could imagine is a guy sends or someone sends money to an account, or we'll just say Ether to an account, and they think that account has code in it, but actually it doesn't, and contract creation failed, and now they have no way of getting the Ether back. So that's something that we could fairly easily recover. And in other cases where people send Ether to an address on the ETH chain where that only has a contract on the ETC chain, so that's also recoverable in the same way. Then the JavaScript bug is also easily recoverable. That's the second case. The third case is people accidentally sending money either to junk addresses or to addresses where they either a zero address or addresses where they accidentally lopped off and missed a couple of characters at the end. So the zero address is kind of hard to recover from, but if it's a few characters at the end, then that's easy to recover from because you could basically just declare an address which is some low power of 16 multiplied by an existing address. And then there's like weird, very special cases, and the Quadriga thing, unfortunately, is like more like a weird special case.
Mm-hmm. I see. Okay, Vlad, what were your thoughts on that, or was that the update you wanted?
Yeah, I mean that sounds pretty reasonable. I mean, I totally get it. Yeah.
Cool. Okay. Anybody else have any other off-topic or non-agenda items to bring up?
So I still have something. Please interrupt me if that was already discussed last week. But so, am I correct in that after Metropolis will change the way addresses are calculated?
Yes, they do. Yeah.
And is the community appropriately aware of that? I mean, there are some techniques where you send Ether to some address and then have a transaction that is not yet published, which will later create a contract at the address. And these things will fail after Metropolis, right?
Right. Yeah. So the community should definitely be made very aware of that. And so, I mean, one nice thing is that if we do commit to 156, then like anyone who isn't, or to at least the first part of 156, then people who aren't aware will basically just like automatically fall into that first class where they send Ether to an empty contract. If we end up deciding that it's too risky, then we could always like do some weird bit flipping thing where we. So like one example would be that a way of making this change totally safe is we make it apply only to EIP86 transactions. So actually no, that would be weird because that's fine. Yeah, so we make it only. So if we cared about making this change like completely safe, no risk, then we'd make it only apply to transactions where the sender is the null sender. And
then we also have to. I mean, it also applies to the create opcode, right?
Right, but no, it doesn't apply to the create opcode. And remember, that's why we created the create2 opcode.
Oh yeah, right.
Mm-hmm. No.
Okay, so the concern is the community not realizing the breaking change, or would it be considered a breaking change from the point of view of most app developers?
Yeah, sure.
No. So like the main risk that I see is that well, actually, I mean, I don't think there are many users that rely on creating contracts or sending to addresses that are not going to exist for a year. The main if you told me that Guy X, or someone lost money because of this, then I would bet that there's like more than 80% chance that it's because of this in combination with another bug that they had. So, like an example would be, let's say someone accidentally sends Ether to a contract or to an account, and that account exists on the ETC chain but not on the ETH chain. And then if we had not done this, then they would have the ability to recover by making the exact same contract on the ETH chain. But because we did it, the address scheme would have changed and they don't have that ability anymore. So like there are going to be cases where this change would increase the risk of someone losing money in combination with them making another kind of mistake. But like those are mistakes that have a large probability of causing them to lose money in it, regardless of what we do.
Yeah, I think it's something to do just before Metropolis. If you are planning to create contracts that certain addresses, maybe after Metropolis you cannot do that. So yeah, before the Metropolis hits, you should do that.
So basically, like, I see two routes here, right? One of them is like slightly higher risk, which is that we are just like be loud right now about the fact that this that this change is happening, and the slightly lower risk thing is we basically just make the change only apply to EIP86 transactions. And like, honestly, I'd be totally cool with making it making it only apply to EIP86 transactions. So like basically only making the change to the way the contract address is created if the sender is the null sender. But like, I'm fine both ways.
Okay, hey, Vitalik, could you do a summary of that and a quick comment on the EIP to kind of bring up the possibility that that can happen? And I think that that can be easily decided on the EIP. And then on 156, and then I'll go back to Christian. I don't think that can go in during Metropolis. I think it was determined last meeting that it's basically we don't have the time and the testing and all that other stuff. But if it were to go in the future, would it be a higher level of difficulty to do specification 1 or 2 of EIP 156 in future hard forks, or would it be the same level?
You mean like, is it harder to do it in Serenity versus doing it in Metropolis?
Correct.
I expect not.
Okay, I was thinking the same thing. I mean, for specification, for the ones like that are more special cases that we would have to come up with a system for, and we're kind of leaning toward not doing in the first place, that would be harder over time just because of the community growing and getting consensus over things. But yeah, for the other two, because they're technical, I think this can be brought up in later meetings for hard forks. Christian, did your comment get fully answered?
Yes.
Okay.
So I mean, perhaps we should also just directly reach out to the community and ask whether someone is using that, and that they are ask whether they are aware of that change. Okay. And from the response coach, whether we, how we specify the creation.
Okay, great. I can in the next week send out kind of a post across all social media channels and Gitter channels. Anything I'm kind of in, but beyond that, I think that's pretty much all we can do. And so I might even sticky it to Reddit if the other mods agree. All right, cool. I think we're wrapping up. Everybody change your passwords and make sure that you have 2FA enabled that is not SMS that's on Google Authenticator, because we had 2 mods of Reddit this morning. Their passwords were compromised, and someone either was sending fake messages or went on, and I think they changed like some stuff on Reddit. So go ahead and change everything, and or all your passwords, I should say, cycle through them. Cool. All right, I think we're good here. Thanks, everybody, and we'll see you in 2 weeks.
See you. See you. Bye.
Bye-bye.
Bye.
See you.